9 take 2. Right, it is a reverse mean, so we are given the mean of the combined packets and boxes, and we're given the mean of just the packets, and we're asked to find the mean of the boxes. So when you think about finding a mean, what you normally do is add them all up and then divide them by how many there are, and that gives you your mean. Now what we've been given here is for the sweets in the packets and boxes together, of which there are 30, we've added them all up, divided by 30, and our answer is 14. And for the sweets in the packets, we've added them all up, divided them by 18, and the answer is 10. So what we need to do is find out how many sweets do we have altogether, how many sweets are in the packets, and then if we subtract them, we'll know how many sweets are in the boxes, and we'll then be able to calculate the mean for that. Now basically, to work out what this is, if that was a division, I need to multiply these two together. So I'm going to do 30 times 14. So 3 times 14 is 42, so that's going to be 420. And here I'm going to do 18 times 10, which is 180. So I then need to subtract those, so 420 minus 180, and that's 240. Now we know that there are 12 boxes here, so to find the mean, now I know what it adds up to, I'm going to do 240 divided by 12, and that gives me 20 sweets in each of the boxes. Question 10 is a combination question, so it starts off with information about ratios, and it then asks you to calculate some values and so on. So for this, I first of all need to look at the ratio. So my ratio of children to adults is 2 to 3. Now I'm not being given the total amount of people there, I'm just being given the total of the children in the crowd at this point, so that's going to be 6,000. Now if you look at this, you should be able to easily work out that this has been times by 3,000 to make 6,000, so I'm going to do the same for the adults. 3,000, which it makes it 9,000. Now I'm told that each ticket costs £8 for the adults, so this will be times by 8, and then each child ticket costs a quarter of the adult ticket, so a quarter of 8, you just halve it and halve it again, is 2, so I'm going to times that by 2. 2 times 6,000 is 12,000. 8 times 9,000 is 72,000, 8 nines being 72, and then if I add those together I will get the answer of 84,000. Question 11 is using fractional indices. Fractional indices are giving you two different pieces of information. So the first, when it's a fraction, it tells you it's a root, and the root is whatever the denominator is. So if the denominator is 2, it's telling you to find a square root. If the denominator was 3, you would need to find the cube root. So the first thing I'm going to do here is find the square root of 4, which is 2. And once I've done that, I'm going to raise it to the power of 3. So this is 2 times 2 times 2, which is 8. This question has asked you to write down the value of. Sometimes they use the word evaluate. Now you use that in a different way for other subjects. In maths it means to give it a number value. That may be a fraction. It doesn't mean oh, I really like the 4 with that fractional power. Okay, so this question actually is very similar. We've got the root, which is my denominator, so I'm going to find the square root of 16, which is 4, and then I'm going to raise it again to the power of 3, which is 4 times 4 times 4, which is 64. Question 12 is solving an equation. This is using algebra and it's also with a fraction. You can see it's worth quite a lot of marks. So I'm going to start off actually, and I'm going to use the grid method for adding fractions. I'm going to draw quite a large grid. So my first fraction is x over 2x minus 3, and I'm going to put that in a bracket because if you multiply a term, you're going like more than one term, you're going to need a bracket. And here I'm going to have 4 and x plus 1 also in a bracket. Now you put a kiss in the box because you love maths. This bracket is going to be the result of x times x plus 1, and I'm going to expand that bracket so that it is x squared plus x times 2x minus 3,
which will be 8x minus 12. And this bracket I'm not actually going to do anything with at this point other than write it as 2x minus 3 and x plus 1. Now I need to collect the terms here with the sausage. So on the top I'm going to have x squared plus 9x, which is 8x plus that x, and subtract 12, and then underneath I'm going to have 2x minus 3 and x plus 1. Now all of that currently equals 1. Now what I need to do is get rid of this division. So I'm going to multiply both sides by 2x minus 3 and x plus 1. That means that x squared plus 9x minus 12 will equal 2x minus 3 times x plus 1. At this point I do need to expand this bracket, so I'll do that quickly up here. You can use whichever method you like. I will use the grid method. This one doesn't get a kiss in the box because I need everything that gets times. So this is 2x squared plus 2x minus 3x minus 3. So my equation is now going to be x squared plus 9x minus 12 equals 2x squared plus, so let's simplify the sausage, so 2x minus 3x, so it won't be a plus, it will be minus x minus 3. Okay, so at this point I want to make these equations equal 0. Because this has got the largest number of x squareds, what I'm actually going to do is move all of this over, and when it moves over all of the signs will change. So I'm going to subtract an x squared from 2x squared. I'm going to subtract 9x from minus x, and I'm going to add 12 to minus 3. So this is going to give me x squared, then minus x minus 9x is minus 10x, and minus 3 plus 12 is plus 9, and all of that now equals 0. Now this is a question on the non-calculator paper that can be solved by factorising. So I'm going to put this into two brackets because there isn't a common factor for all three of the terms. So my brackets are going to begin with x, and I'm looking for numbers, two numbers that multiply to make 9 and add to make minus 10. Now those two numbers are going to be minus 1 and minus 9, because minus 1 times minus 9 will give me a positive 9, and minus 1 minus 9 will give me a minus 10. Now this means that my solutions are going to be the result of this. X minus 1 equals 0. In that case x would equal 1, or x minus 9 equals 0, in which case x would equal 9. Now they're quite mean on these because it is a quadratic. They don't necessarily indicate that you need two solutions, but your solutions are 1 or 9. So it's a lot of work for those 5 marks. Question 13 will seem like a breath of fresh air after that, so we're just trying to make y the subject of the formula. So the first thing I have to do is undo this square root sign, which is affecting everything over there, and I do that by squaring both sides. So So this side it will become p squared, and on the other side the square root sign will remove and we'll be left with that. I then want to get rid of the 5, so I'm going to times both sides by 5, giving me 5p squared equals x plus y. And then to get y on its own, I'm going to move x over here, effectively subtracting an x, so that 5p squared minus x will equal y, and y is now the subject of the formula.